When running an experiment, there might be specific treatment comparisons that you are particularly keen to assess. These comparisons can be incorporated into an analysis of variance using contrasts. Let's import some data so we can work through an example in Genstat. From the menu, select File, Open Example Datasets. From the drop-down list, select a Guide to ANOVA and Design. This action filters the data files to display only those files that are used as examples in the ANOVA and Design Guide. Here's a tip. You can access the ANOVA and Design Guide by selecting Help, Genstat Guides, ANOVA and Design. Now, back to our tutorial. The file canola.gsh is already highlighted, so click Open Data to open this dataset. The spreadsheet contains the results of an experiment on canola with 2 treatment factors. Factor N represents 3 levels of nitrogen, and factor S represents 4 levels of sulfur. The experiment was laid out in randomized blocks with 3 replicates. The variable to be analyzed is yield. We're going to analyze the canola dataset using a 2-way analysis of variance in randomized blocks. From the menu, select Stats, Analysis of Variance, General. In the Design field, select 2-way ANOVA in randomized blocks. Double-click Yield to move the response variable into the Y-variate field. The cursor automatically moves to the Treatment 1 field, so the available data pane updates to list the available factors. Double-click N to move it into the Treatment 1 field. Double-click S to move it into the Treatment 2 field. Lastly, move Block to the Blocks field. Now click Run. To view the output, move up to the toolbar and click the Window List button. Select Output, then click Activate. In the Analysis of Variance table are the F statistics and p-values for the nitrogen, sulfur, and interaction terms. Tables of means and standard errors of differences are also given. Sometimes there are specific comparisons between treatment means that you wish to assess. For example, you may have had an initial suspicion that there would be little difference in the mean yield between the 180 and 230 levels of nitrogen, but a large difference between those with the 0 level of nitrogen. You can test the significance of these individual comparisons using contrasts. To see this, let's fit a single mean for the 180 and 230 levels of nitrogen and assess the contrast between this value and the mean for level 0. You can define contrast like this using the ANOVA contrast menu. If the window pane isn't displayed on the left, go to the bottom of the screen and click the Window tab. Now double-click the Analysis of Variance menu to bring it to the front. Click Contrasts. As we want to assess comparisons between the levels of nitrogen, double-click N to move it to the contrast factor field and set the contrast type to Comparisons. The contrast matrix field is used to name the matrix that defines the contrast. We'll use the default name. Leave the number of contrasts field at 1 as we want to fit just one contrast. Now click OK. This opens a Genstat spreadsheet where we can define our contrast by typing into the cells. We can also provide our own name for the contrast. Click the Analysis of Variance menu to make it active. The treatment 1 field now contains a function of n, defining our contrast. Before we run the ANOVA, we'll select what output to display. Click Options. We'll display the ANOVA table, p-values and estimated contrasts. Deselect the other options. Click OK, then click Run. There is now an extra line in the ANOVA table output under the main effect for n, giving the degrees of freedom, sum of squares, and p-value, etc. for the overall contrast. There is also an extra line under NS interaction. This represents the interaction between the contrast and the sulfur factor. Both are statistically significant. The table of contrasts shows the estimated contrasts. The estimate of the overall contrast is 0.754 with a standard error 0.0749. In this table, we see how the overall value of the contrast varies according to the level of S. For example, at level 0 of S, the estimated contrast is 0.754 minus 0.35.